was actually my first career, was building race cars. And there's a project that many of us want to do in kind of the hacker community. You know, it's rapid prototyping, CNC mills, but it's very costly to get these precision components. So I want to show you how I did a rear suspension on one of my race cars and how we can use that to use lower cost parts to have high precision CNC XYZ tables. This is the back of the car. This is where that rear axle would be. So right in the center of this assembly is the rear axle, and the wheel would be right in here like this. So what I'm showing here is a Watts link suspension, and the way this works is there's the solid frame through here, and there's a pivot point that is mounted securely on the frame. It runs forward to a thing called the bird cage, which is a floating bearing that floats around the axle. And then there's another pivot here so it can be free to float. And then at the bottom of this bird cage assembly that's floating around the axle is another rod assembly that runs up and securely attaches to the frame. So if you look at this, you can see how the rear end can't go forward or backwards. Now there's some other bars in the suspension that I'm not going to go into right now, but I want to focus on how this birdcage suspension works. I also want to point out where the spring is in this system. On this lower control arm, I would weld a triangular bar called a cantilever bar, and this would hook on and be welded solid, and then there would be a coilover spring and shock that would be compressed between the frame and this assembly. This is really important because we're going to use the same thing when we do our CNC table. So when the rear end goes up in the car, this whole assembly rotates around this pivot point, compressing this spring, and the spring pushes back and keeps the car in the air. When this moves up and down, this arm will scribe an arc in this direction. When it moves up and down, this other arm in the opposite direction scribes an opposite arc in the opposite direction. Now, when these move up and down, since this is floating in here, the arcs cancel each other out. This assembly rotates back and forth, but the center pivot point far from perfect. But this is an equivalent to the race car chassis suspension. So in here is this pivot point, this black spot, and up here is an upper linkage that is equal to the distance to this pivot point. So you can see there's a pivot point over here, there's a pivot point over here, and I've extended this lever arm out so that we can have mechanical advantage and a reduction in motion. So a big motion makes a much smaller motion over here. So if we take a look at this, you can see I've scribed the marks on this piece of board of where these arms are moving up and down. And you can see that the center rod is rotating around that pivot point. Again, I'm just using duct tape here, so it's not the perfect joints in here. What a lot of people at home try to use for making CNC machines, or there's projects, there's initiatives called RepRap, which is a rapid prototyping machine that is open source. But they use these threaded rods, and this is something you can go to the home improvement store and pick up. It's just a long threaded rod, and then you put a nut on it. But you can see almost anything you get is going to have a lot of play in the threads. People go and do a lot of effort to put opposing nuts and put pressure between them to take the backlash out of this assembly. So what I'm proposing is that we use this lever arm to amplify the motion. So you travel perhaps twice as far on this rod to move the distance of one out on your workpiece. And by doing that, every time you double the ratio, you're going to half the slop. Now, part of the reason that I'd like to turn things into rotary motion instead of linear motion and using cross slides and these really expensive recirculating ball screws is there's a lot of sources for precision bearings, things like VCRs and hard drives that have bearings that are incredibly precise. I mean, if you've ever taken apart a hard drive, you can see that there is very little backlash in any of these bearings, or in a VCR, the head on it is extremely precise. So we can harvest these bearings or these assemblies and use these. Now, there's one other concept I'd like to throw out there real quick while I'm talking about CNC machines and using precision bearings. Oh, here's another assembly I thought I would show. This is called a Heim joint. This is a rod end, a bearing end. This is what I would use on the race car. It's even got some of my old race car grease on it. But this is another option to rotary bearings, and these actually work very nice because they are bearing in multiple angles, so you don't have to have as precise alignment on them. So, okay, now that we have a lot of computing power and a lot of smart people in the chat room and everywhere else and watching these videos, there's another concept we can do. We can have, instead of using all of this linkage in here and adding, big bars out and threaded rods with pivot points and motors on pivot points, we could do a rotary table or a arc type table. The arc type table might be a little bit better to show. So we have a precision bearing point. We have a rod that gives us the reduction. We have our threaded rod and our motor that's pushing this thing back and forth. So this thing is scribing an arc back and forth. Now we could have on top of this a platform which has another one of these rods that's driving another platform in the other axis back and forth. And we can have computer control correct for the arc that is being created. So that might be another option for us.